All right, so like I said, this is 8.4, and it deals with theorems about zeros. And that's what this whole section's about, is those zeros, okay? So before we start getting into some of these college algebra problems, I'm gonna refresh y'all on foiling imaginary numbers and radicals. So what we're gonna do, we're gonna foil this one first. 8 plus square root of 2 times 8 minus square root of 2. Because we'll have to know how to do this in this section, okay? So notice these are what we call conjugate pairs. Everything's the same other than one's being added and one's being subtracted. So these are called conjugate pairs. And y'all, anytime you foil conjugate pairs, you'll notice the middle terms always cancel out. Now, another thing to know in this section is when you multiply a radical times itself, like a square root of 2 times a square root of 2, we got a formula for those that says anytime we multiply a radical times itself, we would get a square root of a squared, because a times a is a squared. But y'all, the square root of a squared is just a. So anytime we multiply a radical times itself, we get what was under that radical, okay? So that's going to help us in this section. So I'm going to FOIL this. X times x gives me an x squared. X times a negative square root of 2 gives me a negative square root of 2 times x. Notice, since the x wasn't under a radical, you cannot put it under the radical with that 2 when you're forming this, okay? So it sort of goes out to the side of it. Now we take the square root of 2 on the inside, multiply by x. We get a positive square root of 2 times x. And then square root of 2 times a negative square root of 2 gives me a negative square root of 4. But remember, that square root of 4 is going to come out in a second, and you'll see this being happening to it, okay? So, y'all look in the middle of this. You got a negative square root of 2 of x, a positive square root of 2 times x. Those cancel. So I get my x squared in the front. That's a negative. And then the square root of 4 is 2. So basically, when I multiply the square root of 2 times the square root of 2, I get a 2 out of that, okay? So remember, conjugate pairs always cancel in the middle. So I'm going to show you a shortcut way to FOIL for conjugate pairs. So if you notice you got conjugate pairs, we can FOIL this away. Since the middle terms cancel, all we got to do to shortcut this is do the x times the x. So the first thing times the first thing gives you an x squared. And then you multiply the last two things, which is the square root of 2. So remember, square root of 2 times the negative square root of 2 in the long run gives me that negative 2. So we're going to get used to multiplying a radical times itself, and all we get is that number under there, okay? All right, so that was radicals. Now we're going to FOIL conjugate pairs of imaginary numbers. Now I'll do this out the long way, but these are conjugate pairs again. All right, so I'm going to find out who one of these is. Let me see if they're in yet. Y'all hang on just a second. All right, y'all, I just had someone log in under Tori. Who is this?
It's Victoria. My computer was acting crazy, so I went ahead and logged in on my phone. I'm sorry.
Victoria?
Yes.
Oh, okay. So you're already on here. Okay, good job.
Okay.
All right, now the thing up here, when I did radical times radical, I got an A. So here it's possible we end up with an I squared. So remember, I squared would be a square root of -1 times the square root of -1, which in the long run gives us a -1. So once again, I squared equals -1. So anytime I get an I squared, I'm going to replace it with -1, okay? So let's pull this one out, and you're going to see the same thing happen. You're going to get stuff to cancel like that one. So we got an x times the x is an x squared. X times -5i is a -5ix. Now we get it on the inner, we get a positive 5 times x, which is a positive 5ix. And y'all at the end, 5i times -5i is a -25i squared. So notice in the middle, those cancel. So I got my x squared. Now remember, we just said I squared equals -1. So replace the I squared with a -1 and multiply by the number in front of it. So that -1 times that -25 makes that a positive 25. And y'all, you should have shortcutted that, and you could have did x times x and got an x squared. 5i times -5i. That would have gave you -25i squared, which would have turned into a positive 25 on that. All right, so Sylvia, if your mic's not working, you can just use the chat box. I'll keep this thing open on the side. That way I'll see if you actually got a question or not, okay? All right, now here's things about this. When you FOIL radicals, it's always going to be negative in the middle. It'll be x squared minus whatever number. When you FOIL imaginary numbers, they're always going to be positive in the middle, because that I squared always turns that negative into a positive on those, okay? And this one's always negative at the end because you got unlike signs. All right, so that's the first thing that's going to help us in this section. So 8.4 for the college algebra, it starts out having us find polynomials given the zeros. So we're going to find polynomials given the zeros. Now, some things that will help us in this section of 8.4. Radical zeros, like we had up there, radical zeros always occur in conjugate pairs. So what that means is square root of 5 is a 0, then negative square root of 5 automatically becomes a 0 also. And it's just like that with the imaginary. Imaginary zeros always occur in conjugate pairs. So if 2i's is 0, negative 2i's is 0. If 4 plus 3i's is 0, then 4 minus 3i is 0. Okay, so Radicals and imaginary zeros always occur in conjugate pairs. So now, the steps that I use to find my polynomials. The first step, I write the zeros as factors. Now remember, the zeros always have an opposite sign than the factors. So write that, zeros have opposite signs than the factors. All right, after that, you're going to have a lot of stuff in parentheses. So you're going to FOIL until done. So y'all, we might have to FOIL 2 or 3 times on these, okay? Now, if we have zeros of 0, then we have factors of x for those zeros. So when y'all was doing your factoring the other day in 8.2, and you had single x's that were factored out, those always gave you 0 for that 0. So anytime I have a 0 that is a 0, I'll just use an x for its factor instead of putting it into parentheses like my other factors, okay? All right, then let's see what else. Simplify by combining your like terms. Okay, so let me see. Problem number 1 doing this. So let me flip this over. So for the first 5 or 6 in the homework, they're going to want us to do this. Find a polynomial of the given degree given the zeros. So y'all, for number 1, they want a polynomial degree 3 with zeros of -2, 3, and 6. So they're giving me 3 zeros, and all these are real numbers. And they want me to find a polynomial. Now, what they mean by polynomial degree 3 is that when I'm done, the highest exponent has to be a 3 in my polynomial. Remember, first step, write these zeros as factors. So since all these are integers and they're not equal to 0, I'm going to put 3 sets of parentheses. Now, these are the zeros, so they're going to be opposite in sign when I put in for my factors. So the first one, since that's a -2, will be an x plus 2. The second one was a +3, so that factor will be an x minus 3. And then the last 0 was 6, so as a factor, that'll be x minus 6. Because remember, these are like the answers. So I'll show you how I got the factor. If the answer was -2, the same as the 0, To get a 0 on that side, you would add 2 to both sides so that you get your x plus 2 equals 0. So that's why all these will have opposite signs, okay? So now we said, since these are all in parentheses, we're going to start foiling these. Now, it don't matter which two you foil first. I usually just start at the back so that I've always got the smaller one up front. Because y'all, when you multiply these two together, in the long run, we're going to end up with 3 terms out of that, okay? So what I want to do is bring down the x plus 2 and then start my next set of parentheses for this one I foiled it. So y'all, here we go. X times x is an x squared. X times -6 is a -6x. -3 times x is a -3x. And then that -3 times that -6 is a +18. So can we go any further inside these parentheses before I start foiling with that? So let me ask y'all this. Is there any like terms inside those parentheses?
Can we cancel 6x and 3x?
Yeah, just add them together right there, okay? So those are like terms. So bring down your x plus 2. And this will give me a x squared. -6 and -3 give me -9x. And then plus or 18. Because you'd rather foil 3 things than 4, okay? All right, so now these 2 get multiplied by them 3. So we're going to do a longer foil on this one, okay? So both of these get multiplied by all 3 of these. So that's going to give me 6 things here. Up here, when you had 2 times 2, you had 4 things before you added like terms. This will give me 6 before we add like terms. And since this is the last stuff I got to foil, I won't use parentheses. So I got an x times the x squared is an x to the 3rd. X times that -9x is a -9x squared. X times 18 is an 18x. Now we distribute the 2. 2 times x squared is a +2x squared. 2 times -9x is a -18x. And then finally, 2 times 18 gives us 36. And y'all, the last step is to add any like terms. So I'm going to bring down that x to the 3rd because that's the only x to the 3rd I have. I can add that -9x squared to the +2x squared and get a -7x squared. Oh, look at this. The 18x and the -18x, those x's cancel, right? So at the end would be my +36. So notice, they said it had to be a degree 3 when we were done. And look at my biggest exponent is a 3. So we got a degree 3 polynomial out of them zeros. So y'all, that's the trick on this, is to get the zeros, turn them into factors. Once you got them factors, start foiling. Now this one don't tell me what degree I should end up with. It just says write a polynomial with zeros of 3, 6i, and -6i. So remember, the imaginaries always come in conjugate pairs. That's why you got one positive and one negative here. So I got 3 zeros, so I'm going to write 3 parentheses. Remember, the only zero I'm worried about that I'm going to do different than parentheses will be if the zero is a zero, okay? So now, change all the signs, put them in as a factor. So that's a positive 3, this will be a negative 3. That's a 6i, this will be a negative 6i. And then for the negative 6i, it'll be a positive 6i. So I'm going to write that here, change signs and write as factors. Well, I got a lot of people getting knocked off their internet tonight, it looks like. Yeah, because all y'all are already in here. All right, so I'm pickier on this one. Up here, I didn't care which 2 you started with, but when you got imaginary zeros, I would definitely start with those when I FOIL. These are conjugate pairs. So since these are conjugate pairs, I'm going to shortcut FOIL those. So I'm going to bring down that x minus 3. And then start parentheses for this. So remember, since they're conjugate pairs, the middle terms will always cancel. So all we got to do is multiply that x times x and get an x squared. And then multiply the last 2. The negative 6i times the positive 6i gives me a negative 36i squared. So y'all remember this. I said I'm going to turn that I squared into something. Replace the I squared with a -1. So I'm going to bring down the x minus 3. This one will now become an x squared. So all the I squared's purpose in life was to change the sign of that negative 36. Because a negative times a negative makes that what? A positive 36. And remember, imaginary numbers always come out as positive when you're done FOILing those conjugate pairs, okay? All righty, now, all we got to do here is FOIL that the long way because these are not conjugate pairs. We can only shortcut when we got the conjugate pairs. So here, I'm just going to do the x times x squared and get an x to the 3rd. X times 36 and get a positive 36x. Negative 3 times x squared is a negative 3x squared. And then y'all, that negative 3 times 36 is a negative 108. So y'all, I will say this. There's no like terms there, but I would probably do one thing to that problem. What y'all think? So how about, only thing we worried about here is maybe putting it in order, okay? So do your x to the 3rd minus the 3x squared plus the 36x minus the 108. So just put it in order and be done, okay? All right, next one, y'all. The next one I do will have the radicals. So for number 3, it's going to say write a polynomial with zeros of square root of 3, negative square root of 3, and 5. So once again, remember, since these are radicals, they always come in conjugate pairs for the zeros also, okay? All right, I got 3 things. I'm going to make 3 parentheses. All right, so let's see what we get. That's a positive square root of 3, so that's going to come in as a negative square root of 3. That's a negative square root of 3, so it'll be written as a positive square root of 3 in factor form. And then that's a positive 5 in factor form. That'll be a x minus 5. So I'm going to start with these two in the front this time, because those are conjugate pairs, and I can actually shortcut FOIL these ones. Okay, because once again, the middle stuff would cancel again. So for my first parentheses, I got an x times x, which is an x squared. Negative square root of 3 times a positive square root of 3 is a negative 3. Now, remember, you got a negative square root of 3 times a positive square root of 3. Technically, that's a negative square root of 9, but the square root of 9 is 3, so that's how I got a negative 3 out of that. Radical times itself gives you that number in the long run. All right, now I'm going to bring down the second parentheses, which is the x minus 5. Now, these are not conjugate pairs, so we will FOIL them out the long way. So x squared times x is an x to the third. X squared times negative 5 is a negative 5x squared. Negative 3 times x is negative 3x. And y'all, finally, the negative 3 times the negative 5 gives us a positive 15. So notice there's no like terms, and this one's actually in order already. X cubed, x squared, x, and then my number. So are you noticing this? The number of zeros that I have ends up being the degree of the polynomial when you're done. All righty, so let me try this one with the fraction. Write a polynomial of degree 3 with zeros of negative 1/5, 0, and 4. So this is what I was talking about. If you got a 0 of 0, you can't put a 0 in parentheses because x plus 0 would just be an x. So anytime you got a 0 of 0, the only factor you put for it is an x. Now the other two that are not zeros, I will put both of them in parentheses. But remember, anytime you got a 0 of 0, the only factor you're going to get is the x. Now, that was negative 1/5, so this will be x plus 1/5. That's a positive 4, so this one will be x minus 4. Now, when I got the single x's, I'll wait till the end, and then I just distribute them from whatever I get. So what I would do on this, y'all, is start with these two and FOIL them first. So bring that x down. And then we'll start our parentheses. So we got an x times an x. That's going to give us an x squared. X times negative 4 is a negative 4x. 1/5 times x is a positive 1/5 x. And then at the end, we got a 1/5 times a negative 4. That's going to give us a negative 4/5. So remember, anytime you got a single number and you multiply it by a fraction, you multiply it by the top number only. So I did the 4 times 1, got a 4, put that over to 5. All right, so that finishes out those parentheses. But before I can go on this, look in the middle. I got like terms. So we got to figure out what -4 plus 1/5 is going to give us so that we can add them together. So I'm going to put a 1 under this because I'm adding. I need a common denominator, which will be 5. So I'm going to multiply the top fraction, top and bottom by 5. So I get a -20/5 plus 1/5. So that's going to be something over 5. So let's see what we get on top. -20 and 1, give me a -19. So that's what I'm going to replace the middle with. So I got my x squared minus 19/5x minus, at the end is a 4/5. Now I'll say this. If you don't like adding fractions by hand, look, we got a calculator. Let me show you how I'd punch it on the calculator. So if I wanted to do -4 times plus 1/5, I would do -4 down here plus 1/5 would just be 1 divided by 5. Now this will give me a decimal. To turn a decimal back into a fraction, you hit the math button on the left side, and then you hit enter twice. It brings it on the screen. It says now I'm going to turn my answer into a fraction. That I get my -19/5. Okay, so if you got to add on that, use it. All right, we combine like terms. Now I use this x and just multiply by everything inside the parentheses. So you're basically distributing it. X times x squared will give you x to the third. X times -19/5 x, give me -19/5 x squared. And then x times -4/5 gives you -4/5 x. All right, we have no more like terms. Final answer. All right, y'all notice this. I had 3 zeros. Once again, I ended up with a x to the third. So the number of zeros you have will equal your degree when you're done, okay? All right, so I'll probably need a bigger piece of paper for this next one we got coming up. So y'all, number 5, polynomial of degree 6. So that means there's probably a lot of pulling since this is a degree 6. And then it tells me with -2, a 0, multiplicity 3, 0, a 0, multiplicity 2, and then 2 is a 0, multiplicity 1. So remember, multiplicity is telling y'all how many times these zeros are occurring. So that means we're going to write this one 3 times. 0 has multiplicity 2, we'll write it twice. And then 2 has multiplicity 1, we'll write it 1 time. But remember, for the 0, I'm just going to put an x for each 0 that I have that is a 0. So for the 0, you would get an x times an x. That takes care of those 2. Then I'll put parentheses for the other 4. Remember, all I'm going to do is change the sign of this one so that it is an x plus 2 3 times. The 0 of 2, I'll change it to a -2 one time. So let's see if I got my 6 x's. I got 1, 2 here from the zeros, 1, 2, 3 here from the -2, and then 1 from the +2 over here. So y'all, this is just a lot of foiling. Now in the beginning, we know what the x times x is. That's going to give us an x squared in the very beginning. And all I'm going to do at this point is FOIL these last two. So I'm going to bring down everything else. And guess what? These are conjugate pairs at the end. You got a +2 and a -2. So we're going to shortcut those. Shortcut FOIL anything that's conjugate pairs, whether it's radicals, imaginary, or whole numbers, okay? So to shortcut it, x times x is x squared. 2 times -2 is a -4. All right, so that one's done. So now I'm going to FOIL these together. These are not conjugate pairs, so we're going to FOIL this one out the long way. So I'm going to bring down the x squared and the first x plus 2. So now I'm going to FOIL the x plus 2 times the x squared minus 4. So the x times x squared is an x to the third. X times -4 is a -4x. 2 times x squared is a 2x squared. And y'all, finally, I got a 2 times a -4 is a -8. Now you notice there's no like terms inside here. And I'm not even going to worry about putting it in order yet. We can do that on a final answer. So none of these are like terms. So what we got to do is multiply these 4 times these 2. So we're going to come in and FOIL this. The x times all 4 of these, the 2 times all 4 of these. So bring down that x squared in the front. So here we go. X times x third is an x to the 4th. X times that -4x is a -4x squared. X times 2x squared is a 2x to the 3rd. Notice all we're doing is adding the x to everybody. That had 3, it's now got 4. That had 1, it's got 2. That had 2, it's got 3. And then the x times -8 is a -8x. Now we do that with that 2. 2 times x to the 3rd is 2x to the 3rd. It gets long FOILing when you got to get up to a ⁻⁶, y'all, okay? 2 times -4x is a -8x. 2 times 2x squared is a 4x squared. And finally, 2 times -8 is a -16. So we got 8 terms in here. 2 times 4 gives you 8 terms. So I believe there's quite a bit of like terms in here. So I'm going to bring down my x squared. And I'm going to start adding like terms. So the x to the 4th has no one else. So bring down your x to the 4th. Next, I'll do my x to the 3rds. I got 2x to the 3rd. That'll add to that 2x to the 3rd. Give me 4x to the 3rd. Oh, look at my x squared, y'all. -4x squared adds to a +4x squared. They cancel, they go away. All right, now this -8x will add to that -8x. So they're both negative, so that'll make a -16x. So that takes care of the x squares, the x's, everything. At the end is still a -16. So that one had quite a few like terms, and even some of them canceled out that were opposite in sign. So now the easy part, we got an x squared sitting out front. We're going to distribute that x squared to everybody. So x squared times x4 is an x to the 6. All I'm doing is adding those exponents on these variables. X squared times 4x to the 3rd is a 4x to the 5th. That x squared times negative 16x is a negative 16x to the 3rd. So remember, there's a 1 there. 1 plus 2 gave me 3. And then finally, the x squared times a negative 16 is a negative 16x squared. All right, so you notice none of these are like terms. So that is our final answer. All right, so let me do one of these like number 7. So this will be for y'all to answer. Now you don't have to pull on this one. This one says, suppose a degree 4 polynomial. So remember, if it's a degree 4, it has up to 4 zeros. So they're saying, suppose a degree 4 polynomial has zeros of negative 2, square root of 5, and 11 halves. What is the other zero? So going off of what I said today, they're saying 3 of your 4 zeros are a negative 2, a square root of 5, and 11 halves. Anyone want to guess what is my other zero?
0.
Negative.
I tried.
Think about what I said. I didn't say nothing about fractions earlier, right? And I really didn't say nothing about these negative 2s having something special. But while ago, let me find it. We made some stars right here. So remember, one star said if it's a radical 0, they always got to come in conjugate pairs. The other star said if they're imaginary zeros, they always got to come in conjugate pairs.
So is it a negative square root of 5?
That's it, y'all. That's all you do on these ones like this, okay? So if they give you a square root of 5, then that automatically means that that negative square root of 5 is a 0, okay? All right, so try this one. So suppose a degree 4 polynomial again. Has zeros of I and 8 minus square root of 11. What are the other zeros? Now they're telling a degree 4, so we better get 4 of them. So you got an I sitting there. So what's the conjugate pair of a 1I?
Negative I.
Now this is 8 minus square root of 11. So remember, this is what we call a complex number. We don't change the sign of the 8. We only change the sign of the radical. Remember how the quadratic formula would give y'all answers like 8 plus or minus square root of 11? So if the radical is negative on this one, you're going to have 8 plus square root of 11. Okay, so you only change the sign of the i's or the radical part of those, okay, when you're looking at the zeros. All righty, so now They give you a few of them questions right there, because now, check this out. For your number 10, so number 9 is doing the same thing as those. For your number 10, they say, hey, find a polynomial of lowest degree. So they're saying that because they don't want to give away the problem with zeros of -4i and 5. So do I just have 2 zeros?
No.
No, because we just went through 2 examples that told us what?
That it would be the opposite of -i, so it would be 4i.
Yeah, if you got -4i as a zero, then 4i is also a zero. So that means we got 3 zeros for this one. So we're going to set them up as factors again because they want me to find a polynomial. So that's a -4i. So I'm going to make that a +4i. And let's get the i's together. So since that's a +4i, this one will be a -4i. And then for that +5, this factor will be x minus 5. Now you could have put in any order you want, but y'all, these are so much easier if you FOIL these imaginary numbers before you FOIL anything else, okay? Now, these are conjugate pairs, so we can shortcut these. So the x times the x will give me a x squared. Now remember, 4i times -4i equals a -16i squared. But remember, I squared equals -1. So that -16 times -1 makes that a +16. All right, now my second parentheses will be the x minus 5. So y'all, here's the thing. Anytime you're going to FOIL these imaginary numbers, it's always going to be plus whatever the number is times the number, okay? All right, so now FOIL these, and we will have our lowest degree polynomial. So x squared times x is an x to the third. X squared times -5 is a -5x squared. 16 times x is a +16x. And then our 16 times -5 is a -80. So just remember, if they want you to find a polynomial and they give you an imaginary or a radical, its opposite is also, or its conjugate is also a zero. All right, so Monday, I taught y'all how to do synthetic division. So let me show you what we got coming up. For these examples, they're saying for the polynomial, a zero is given. They want me to find the other zero. So when we got a polynomial and they give us a zero, we use synthetic division to sort of divide that zero out. And then we take that quotient and start playing with it to find the other zeros. So here's my function. I got f of x equals x to the third plus 4x squared minus 5x minus 20. And then they do a semicolon and put a -4. So they're telling me -4 is the zero. So I need to get me a new quotient before I can guess another zero, okay? So we write out our coefficients. So I'm not missing any placeholders. I got my x cubed, x squared, x, and number. So I'm going to write down my coefficients: 1, 4, -5, and -20. So there's my remainder in the box. Now, since they're giving me -4 as a 0, I use -4 as my C for my synthetic division. So let me ask y'all this. If -4 is a 0 of that polynomial, what will that remainder be?
Zero.
Oh, I think I hear it.
Zero.
0. Yeah, when we're done, that's going to be 0. And then we're going to play with this little coefficients that we get for our quotient in a little bit, okay? So remember, synthetic division, you bring the first number down, and then we start multiplying and adding. So 1 times -4 is -4. 4 and -4 add to give me 0. Then I multiply to get the next number. 0 times -4 is 0. I add that column, -5 and 0 is -5. And then finally, I multiply to get the last number. -5 times -4 is a +20. So at that point, we have a 0 remainder. So we knew -4 was a 0 because they gave that to us. So now this 1, 0, -5 would be the coefficients of the new polynomial. And remember, it would start 1 degree less. So this would be 1x squared plus 0x minus 5. Now, since that's a 0x, this will shorten down to what? An x squared minus 5. All we got to do is set that equal to 0, because it's only, anytime you get it down to an x squared, we can use the quadratic formula, or we can take square roots. So since this had a 0 for the x, I can take square roots by adding 5 to both sides. Again, x squared equals +5, and then take square roots of both sides. So that I get x equals, so we really can't take the square root of 5, but in the front of this number, we got to put a plus or minus square root of 5. So Math Lab will have that plus or minus, or you can do a square root of 5, comma, negative square root of 5, okay? Now, if I go from 3 and I know a 0, once I'm down to 3 numbers, remember, quadratic formula. So you could have used a quadratic formula. A would have been 1, B would have been 0, C would have been -5. You'd have got the same 2 answers. All right, so I'm gonna do another problem like that where they give us 1, 0, and we got to find the others, okay? So this next one will be like 13. So for the polynomial, one 0 is given. Find the other zeros. All right, so we got P of X on this one is going to equal X to the 4th plus 55X squared minus 576. And they're telling me 8i is a 0. So what that means is my C for this one will be the 8i. Now y'all look here, I got an x4, then it goes to the x2 term. So I'm going to put a 0 for the x3 term. Then it goes from the x squared term to the number. So I'm missing the x term. I'm going to use a 0. So my coefficients would be 1 for the x4, 0x cubed, 55x squared, 0x minus 576. Once again, you better get a 0 for that remainder because they told me 8i was a 0. But y'all notice, I'm going to have 1, 2, 3. I'm going to have 4 numbers down here, which means I can't use the quad until I get it to 3. So when I get 4 numbers, those 4 numbers will be my coefficients for my synthetic division the second time I use it, okay? So first, let's get this one out of the way. Bring the 1 down. 1 times 8i is 8i. 0 plus 8i is 8i. Let me ask y'all, what is this going to give me? 8i times 8i goes right here. So that's going to be 64i squared. But remember, 64i squared is really a negative 64. So y'all, the calculator do these i's because if you hit the second button and the decimal on the bottom, there's a little blue I down there. So you can punch in 8, second decimal to get an I, times 8, second decimal to get the I. It'll give you negative 64. All right, negative 64 and 55 give me negative 9. Negative 9 times 8i is a negative 72i. 0 and negative 72i give me negative 72i. And negative 72i times 8i. So you got 8i times a negative 72i. That's going to give you a negative 576i squared. But remember, I squared is negative 1, so that's going to turn that negative into a positive. 576. Add them together, you will get a 0 remainder. So y'all, like I said, you still got 4 numbers, so we cannot use the quad formula yet, or the square root stuff. So what we got to do is bring down them 4 numbers, 1, 8i, negative 9, negative 72i, and we're going to do synthetic division one more time. Once I get these 3 numbers, I can then use the quad to get the last numbers. Or like I said, square roots. Okay, I need me another C that I can use.
Negative 8i.
Oh, good. Y'all are getting on to that. That's a good job. Because they got to come in conjugate pairs. So at the moment, I know one of the zeros will probably be that negative 8i. We just got to find all the other 2, okay? So let's see what happens here. The 1 comes down. 1 times negative 8i is a negative 8i. 8i, negative 8i, give me a 0. 0 times negative 8i is 0. Negative 9 plus 0 is negative 9. And finally, that negative 9 times negative 8i is a 72i. Add those together, we get a 0. So negative 8i was our first 0. So now I got 3 numbers. So since I got a 0 in the middle, I'm going to take square roots. So remember, this is like an x squared plus 0x in the middle minus my 9. I'm going to set that equal to 0 to get the others. So let's add 9 to both sides. But y'all, if y'all are using the program on the calculator for quad formula, A, B, C, with them 3 numbers, then you'll get the same answer. All right, so x squared is a positive 9. Take a square root of both sides. So that x will equal a plus or minus square root of 9 is 3. So we get a positive 3 and a negative 3. So good job. Altogether, it had 4 zeros because it was an x to the 4 up here. They gave us 1. You don't have to give them that one. You just got to give them the other 3, okay? All right, let me get my paper fixed. So what we're about to learn is to help us at the end of this chapter, because they're not going to give us any of the zeros, and they want us to be able to pick numbers out that we could try to use our synthetic division for that would actually find the zeros, okay? Now, I'm going to tell you the truth. I use my calculator to do this part, but you still got to know how to find this. So this section is about finding all possible rational zeros of a polynomial. So to do that, we take all factors of the last number. We'll call that our P, and divide by all factors of the first number. I'll call that my Q's. Now, I'm going to use a plus or minus for every P over Q. Because remember, the factors could be positives or the factors could be negatives. So we'll take all factors of the P divided by all factors of the Q. All right, here we go. Find all possible rational zeros of P of X equals 14x to the third minus 34x squared plus 42x minus 15. So remember, factors of the last number will be the P. Factors of the first number will be my Q. So like I said, 15 will be the P's. So we want all factors of 15. That'll be 1, 3, 5, and 15. Q, the first number was 14. So all the factors of 14 are 1, 2, 7, and 14. All right, so we need to find all combinations of our P divided by our Q. So the first P factor is 1. You want to take that 1 and divide by all 4 of these factors. So I get a plus or minus 1 divided by 1, plus or minus 1 divided by 2, plus or minus 1 divided by the 7, plus or minus 1 divided by 14. So at the moment, since they're plus or minus, I've got 4 factors, but remember, plus or minus means that's really 8 different possible zeros. Now do the same thing with the 3. Divide the 3 by all 4 of these numbers. So plus or minus 3 divided by 1, plus or minus 3 divided by 2, plus or minus 3 divided by the 7, and then plus or minus 3 divided by 14. All right, so 2 of them are done. So now we do the same thing with the 5. 5 divided by 1. 5 divided by 2. 5 divided by 7. And then 5 divided by 14. So now I got 8, 16, 24 possible zeros. And I still got a number left. 15 divided by the 1. 15 divided by the 2. 15 divided by the 7. And then finally 15 divided by the 14. Now, y'all, what they will want us to do, any of these that can simplify, we would have to simplify. So remember, 1 over 1 would give me a plus or minus 1. 3 over 1 would be plus or minus 3. Plus or minus 5. Plus or minus 15. So reduce that one, that one, that one, and that one into the whole numbers. Nothing else reduces. So notice I got 8, 16, 24, 32 possible zeros of this polynomial. And remember, only 3 of them could possibly be zeros because I only got 3 zeros for this problem. But this would give you a starting point if they didn't give you any numbers like they did a while ago. Now, I'll tell you the truth. I sort of graph them to see where the graphs are going across them when I find my zeros. So I'm going to do that with you. A problem where they want you to sort of do that. So this one would be like 16. I'm going to find the rational zeros. Then the other zeros. So what they mean, rational zeros can be fractions or integer numbers. But if you get radicals or imaginary numbers, those are considered the other zeros. So these would be the radicals and the imaginary stuff, okay? All right, so the polynomial will be f of x equals x to the third minus 73x plus 72. Now, when we're done, they want us to factor this into linear factors. That'll be part B. So if I was doing P and Q stuff, this would be my P. My Q would be the first number, which would be a 1. So the factors of P for 72. I've already done them. I got a 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. So 72 has a lot of factors. But look at this, the Q is a 1, and the only factor of 1 is 1. Which means I'm dividing all these P's by 1. So I'm not changing all these numbers. So my possible zeros would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. It's going to be all these plus or minus 8, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 24, 36, and then the 72. So if they don't give you zeros, you just got to start playing with these factors until you get 0 remainders on your synthetic division, okay? So let's start with the first one. So I'm going to pick a positive one from my first C. I'm going to write out my coefficients. I got a 1, We don't have the x squared term, so that's going to be a 0. X is negative 73. Last number, 72. So let's see if 1's a 0, we'll be good to go. Bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 73 and 1 is negative 72. Negative 72 times 1 is negative 72. Oh, look at that. That one gave me a 0 remainder. So I know 1 was a 0. So my 0 so far, I know is a 1. Now, at this point, we got 3 numbers left. So we can use the quad. Now, y'all, I was lucky on that one, that 1 was a 0. But let me show you what you can do to these. I'm going to go to the graph and punch in that little polynomial. So I'm going to go to y equals. And that polynomial was an x to the third. Whoops, let me go back. I got too much. Let me delete that one. All right, let me go down. X to the third minus 73x minus plus 72. All right, so I got my polynomial in there. I'm going to go to the graph first and see if I can see anywhere where it's crossing that x-axis. Oh, y'all, look at it. It's doing 3 times, so I had x to the third. So it looks like this is over here at negative 9. I got the line going across that 1 over here. That's the 0 we just got. And then it looks like this last line's crossing over at 8 on the x-axis. So if I did this quad, I should get those 2 answers. So let's see what and that's you could have used that to pick any one of them zeros and started with your synthetic division on those, okay? Also, let me show you this. Let me go back to that calculator. If you go to the table by hitting second graph, wherever there's a 0, like at 1 for the x's, I got a y value of 0. So you're looking for y values of 0 to find your zeros that are equal to the x's. Right there at 8, I had a y value of 0. So that's another way you can sort of check what numbers to use instead of going through this whole list, okay? All right, so you cannot solve this one by square roots because you got an x term in the middle. So remember, this is like an x squared plus an x minus 72. So I'm going to set it equal to 0 and use the quad. So x equals, so let's see, a is 1, b is 1, c is negative 72. So x equals negative b, which is 1, plus or minus 1 squared minus 4 times 1 times negative 72, all over 2 times a, which is 1. That's a negative 1 bring down, plus or minus. 1 squared is 1. All this is getting multiplied. I got 2 negatives. That's going to make that a positive. And then let's see, 4 times 72 is 288. All over 2 times 1, which is 2. All right, negative 1 plus or minus. 1 plus 288 is 289. All of that over 2. So y'all, I need one of y'all to take the square root of 289 and tell me what that's going to give me. Y'all want me to go to my calculator real quick? Let's see. All right, so let me quit this screen. So I'm going to do second x squared to get the square root. I'm putting a 289 under there. So the square root of 289 gives me 17. So it's gonna be -1 plus or minus 17 all over 2. So let me get my first answer and then my second answer. First answer, I'll do -1 plus 17 divided by 2. The second answer will be -1 minus 17 over 2. So you're on top, I get 16 over 2, which is 8. So the second zero is 8, which we could tell by the graph. And then the third one would be a -18 divided by 2, which is a -9. So remember, I had an x to the third, so I found 3 zeros. All right, so now it said part B, write these as linear factors. That means they just want us to put them in parentheses, sort of like we did when we was doing the polynomials earlier. I got 3 zeros, so this will be x. That's positive, so that'll make this a minus. Positive 8, we'll make that a -8. And then the -9, we'll make that one a +9. So y'all, that's what y'all got coming up. So I will say that number 17 starts out with a 4, an x to the 4th. So use that calculator to figure out a couple of them zeros so that you can use it on your synthetic division. After you do the synthetic division twice, the last 2 zeros you can do the quad formula for, okay? All right, so I'm gonna do is Sylvia, you still on here? Let me find my chat. Okay, Sylvia, you're still on here. So are y'all still wanting me to do 2 of them word problems? Are y'all hearing me? Are y'all still want me to do the word problems? Like on that test? All right, well, I'm gonna do them anyway. So this one says, a wire is stretched from the ground to the top of an antenna tower. So y'all, here's my antenna tower. I got a wire stretched from the ground to the top of that. Now, the wire is 30 feet long. Now they're telling me that the height of this tower right here is 6 feet greater than the distance D from the tower's base to the end of the wire. Well, here's the end of the wire. There's the base of the tower. They just said that was D. And the height of this tower was 6 feet greater, so that'll be D plus 6. So we got a right triangle, so we're going to use the Pythagorean theorem. Now, that says a squared plus b squared equals c squared. The only stipulation, the longest side over here, that hypotenuse, that has to be c, okay? So plug in what you got. A can be to d, so d squared. B would be d plus 6 squared. That's going to equal my c, which is 30 squared. So I made that A and that B. All right, so now it's just a matter of getting rid of parentheses and figuring out what 30 squared is. So bring down the d squared. On the side, D plus 6 squared would be D plus 6 times D plus 6. That's going to give you a D squared plus 6D plus 6D plus 6 times 6 is 36. Add like terms, you get a D squared plus 12D plus 36. So that goes right here. All right, over here, 30 squared, 30 times 30 is 900. So on my next step, I would add like terms and I get a 2D squared plus 12D plus 36 equals 900. So we're basically at the point where we're going to subtract 900 from both sides, because remember, to use the quad, I need to have a 0 over there. So 2D squared plus 12D, let's see, 36 minus 900, that's going to be a negative 864 equal to 0. Now here's something else you can do on this one. On the one where you got the wire, all these are even numbers. So if you want to make it easier to solve, divide everybody by 2. So that you get D squared plus 6D minus, let's see, 864 divided by 2. That's going to be minus 432 equal to 0. At this point, you got quad. A equals 1, B equals 6, C equals negative 432. So all that's big numbers, but I'm going to use my calculator to help me on that, okay? I'm not going to use the, now if you wanted to use the program, you'd go program, quad. Put in your numbers would be 1, enter, 6, enter, negative 432. That's going to give you 2 answers, 18 and negative 24. But since we're looking at distance, only the positive answer is going to count, which is the 18. Now, doing it by hand, negative B would be negative 6 plus or minus 6 squared minus 4 times 1 times negative 432 all over 2 times 1. That's going to bring down that negative 6 plus or minus 6 squared is 36. Now look over here, all that's getting multiplied. You got 2 negatives, so that's going to make that a positive. So let's see what I got. I got 4 times 1 times 432. That gives me 1728. 2 times 1 is now 2 on the bottom. All right, next we're going to add those together. So 1728 plus 36 gives me a square root of 1,764 all over 2. So even doing this by hand, I'm still using the calculator to help me multiply and add this stuff together, okay? So now negative 6 plus or minus, on this problem, this square root will come out perfectly. Watch this. Second, x squared from a square root, 1764, hit enter. That gives me a 42. So negative 6 plus or minus 42 over 2. All right, since all these are even numbers, you can divide both of these by 2 and make this even smaller. Negative 6 divided by 2 is negative 3, plus or minus 42 divided by 2 is 21. So first answer, second answer. First answer you add negative 3 plus 21, which gives me 18. Second answer, you subtract negative 3 minus 21, negative 24. So remember, cannot keep the negative answer. So that means that this D up here is 18. The height of the tower was D plus 6. So 18 plus 6 would give you 24. Okay, y'all, so just remember on this problem, when you set it up, you cannot keep them negative answers. All right, so was there anything else y'all needed? Well, I ain't hearing y'all tonight. Are y'all there? All right, let me stop that.
I'm here.
Okay, so I didn't know. If
Yeah, I'm here too.
I didn't know if all that, all them rational zeros run you off or not. So that was one of the word problems I was asking about. So did that sort of hit y'all a little?